Okay, so just a review of today's lesson on the periodic table. The things that you need to understand after today's lesson is that most of the elements in the periodic table are metals, and that's why we drew those lines to include most of the elements. Okay, so you have to be able to identify these as metals, and these ones, of course, as well, but we're really just going to focus on the group in the main periodic table. Don't forget the columns in the periodic table are grouped according to their reactivity. And the reactivity is because of the valence shell electrons. Because don't forget, chemicals react because of electrons. Electrons are the reason for chemical reactions. Because what happens is the elements either want to give away electrons or take electrons. So let's take a look at what we needed to understand today. We needed to understand that this is an element key, and that the number is, the atomic number is the number of protons and electrons, which are equal in a neutral atom. And we need to remember that when we're talking about atoms in the periodic table, the elements are considered neutral. The symbol is the large letters. The name of the element is printed below, and then the atomic mass is the number that is usually in decimal form. There's a few that aren't in decimal form, but that number at the bottom is the atomic mass. So the element key tells that information. Okay, the next thing that we need to understand is the grouping. Now we have groups which are columns. And the columns have certain characteristics. And if you remember, I told you to remember the 1A, the 2A, the 3A, the 4A, the 5A, the 6A, the 7A, and the 8A. And the reason that's important is because those will tell you how many valence shell electrons each of the elements in that column have. So in this column, all of these elements have one electron in their valence shell. All of these elements in 2A have 2 electrons in their valence shell. And then you got to skip all these ones and come up here to 3A. There's 3 electrons in the valence shell, 4 electrons, 5, 6, 7, and then 8. And these are the guys that are happy because they have their valence shell full. So they don't want any electrons, and they don't want to give away any electrons. Now, the next thing that we have to remember is, from our lesson before, the ionization energy increases as we go from left to right. So that means how much energy it takes to take an electron away from one of these atoms. Remember these guys over here? They're trying to give them away. They're like, hey man, you want my electron? Because they don't want just that one electron. These guys will give away electrons as well. These guys will, and these guys will. These guys will also accept electrons, okay? So that's the 4, because let's say carbon. He has 4 valence electrons. Carbon can actually take 4 electrons from somebody else, or they can give their 4 away. So that's sort of like the boundary between elements that accept and elements that give electrons. So these guys, 1, 2, and 3, want to give away electrons. So those guys would be an electron donor. And then these guys here would be an electron acceptor. Okay? So these guys are acceptors, and these guys are donors. Okay? And don't forget, the whole column has 5 electrons in its outer shell. The whole column has 6 electrons in its outer shell. So now we have to think about when atoms want to give away or accept electrons. If you give away electrons, you're giving away negative charges. So you're actually going to become a cation. So these will become positively charged when they give away their electrons. These will become negatively charged when they accept electrons. And then these guys, they can either become positive or negative because they've got 4, so they can go either way. Okay, the next thing that you need to understand is the rows. And the rows are called periods, and these things, what you need to know about the rows is that as we go from left to right along the row, we add a proton. Okay, so this guy has 1 proton, then 2, then 3, then 4, then 5, then 6, then 7. So as we go along and add protons, every time you add a proton, you change the element. Okay, so you can't have 2 of the same element with different numbers of protons. As soon as the number of protons changes, the element changes.